In this video, we're going to talk about constants and variables, and they're different. And the names kind of imply their use, but I want to talk about these very specifically so that we've kind of laid the groundwork for what we're expecting in this course. Constants are used to save memory and maintenance. Maintenance is important when you have a lot of code that certain things could change, but not very often. And you don't want to hard code literal values into your source code. So constants allow you to have a value that isn't going to change in your code, but it's a value that you need to have available so that you can use it in your calculation. So we'll talk about that. The thing to remember about constants is they're called constants because their value is constant. It does not change, okay? Constants do not change. They are declared once. Whoa, looks like we're doing that over again. Welcome back. In this video, we're going to talk about constants and variables. Constants. Constants save us memory, and they save us maintenance on our code is a good way to say it. Because a constant, by its very name, doesn't change. It's a constant value that I'm going to use over and over. Now, I need the value in my program somewhere, but I don't want to hard code it as a literal value in all of my calculations. I want to refer to it so that it's located somewhere, and if it ever changes, I can change it there, and it's automatically reflected. That change will be reflected in all of my code. They are declared once, and they have global scope. Now, we're going to talk I'm talking to about 5 or 6 of you in particular over the next couple minutes. And I'll unpack that in a minute, but they are not global variables. They are global in scope, meaning I can access that value anywhere in my code, but it is not a global variable. Global variables are evil. Do not use them in my class. Do not turn in code in which you have global variables. And when we get into why they're bad as we go through this course, you'll hear me say this over and over and over again. A well-designed program will never need global variables. Constants that do not change but are global in scope save time and memory, okay? And they are authorized. And a good example of what you might use would be a tax rate. So if I said in C, hashtag define tax rate 0.07, then anytime I refer to tax rate, it's going to pull up 0.07. Notice that constants are all capitalized. Okay, that tells me when I'm reading your code, oh, that's a constant. Anything with a hashtag is a preprocessor command, which means this token is stored really before it's even processed my code. Okay, that's how simple this is. It's just wherever I see tax rate, I'm going to put 0.07 into the calculation. It stores it once. I may use that in 500 different calculations. So if the tax rate goes to 0.08, I go 0.08, recompile that one, it's updated. Okay? So that's what that's a constant. All right? So, all caps for naming for your constants. You can use the underscore to string words together, since camel casing is a little hard to read when it's all caps because that's not camel case. All right, now let's talk about variables, and I'm going to use C as the language to talk about variables because that's what we're getting into first. All right, you can declare, define, initialize, and modify variables. Now that sounds like a mouthful at first, and it kind of is, okay? And the difference between declared and defined is kind of weird at first. It almost looks like it's a difference without a distinction. But we're going to talk about it. So declarations, and when you declare a variable in C, and we're not going to need to do this for the code we're writing in this class, okay? But declarations tell the compiler, hey, this variable really does exist. And it's used for when I'm linking a bunch of files together. And I may reference a variable over here, and the compiler may get to it and go, wait. Does this really exist? But since it's already gone through all of its declaration checks, oh, you're referencing this here, you haven't defined it or declared it yet, or you haven't defined it yet, but it's declared over here, so I'm going to trust that this does exist. Okay? And declarations begin with extern, meaning external. So any other files that use this variable, it's real, you're going to see it somewhere. Okay? When we define them, we are giving them a data type and a variable name, and that may be all we give them. We're saying, okay, int C, semicolon. So we're saying now I am going to define C as an integer. So in C, it's going to run and give me 4 bytes of memory as an integer, okay? And it's going to put a label with the letter C pointing to it. All right, so I've got a token C that points to that. And again, we'll get into this in the language series, but basically when I define it, I'm giving it a data type, so I get a memory location with enough memory to hold whatever it is, and that's why the data type matters, okay? And then when I initialize it, I give it an initial value. Now, modern compilers will try to help you with that. If you declare an integer, it'll give it a 0. If you give it a float, it'll give it a 0. Never, ever, 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 ever assume that your variables are properly initialized. We will always initialize our variables correctly to make sure that we didn't miss anything. Because when you get to reference types, if you haven't initialized them, you have null, and you can throw what's called a null pointer error, and everything comes crashing down around you. Okay? So we're going to always initialize our variables. And then modifying is why they're called variables. The values may change. If my int sum equals 0 is the integer that I've defined and initialized to keep the sum of my grades, so I can divide by the number of my grades and get my average, okay, sum is going to change every time I add a grade to it. Okay? So they're variables because the values in them change. All right? Now, the definitions set the instance in a file, method, or block of code. So what that means is when I define a variable, what I'm really saying is, hey compiler or interpreter, go get me a chunk of memory, name it whatever name I just gave it, okay? And then I'm either going to put a value into it or I'm going to put a value in later. Okay? If I say int x equals 4, I'm saying go get me an integer and put the value 4 in there. And we're going to really unpack that one in a bit. Okay. The variable is on the left side of the assignment operator. And we're going to really unpack this here in a minute. But there's the left-hand side and there's the right-hand side, and in the middle is the assignment operator. Okay, the variable goes on the left. That's the storage location. And the value that we're going to calculate to put in that is on the right-hand side. Okay? So, the L value in computer science means the left-hand value of what casual observers call the equation, but it's really not. It's the left-hand side of the assignment operator refers to a memory location. And the R value, or the right-hand side, refers to a value that is calculated to then be stored in the memory location on the left. So here we go. Int x equals 4. I've done an hour-long lecture on that statement right there. Okay? Because there's so much to unpack in int x equals 4. So let's talk about it. The first thing that's happening is we are giving a data type to a variable that we want to create. So int, I need whatever int is in this language, however many bytes I get, I need that grabbed from RAM. Okay, now it may be actual RAM, or if I'm out of RAM, it may be a location on my hard drive called virtual RAM. But somewhere is memory that I get 4 bytes. Okay? And I'm telling the computer that the token or the variable name I want assigned to it is X. So there's a table somewhere that says X, and then there's a memory location. Okay? And then this, I don't ever want to hear my students call the equal sign ever again. In computer science, that is known as the assignment operator. Because it's not testing for equality. Okay? We do that as a shorthand symbol that's easy for our brains, but what you really should have is like an arrow here, because I'm saying whatever's on this side, put it in there. So I've got 4 bytes of memory with a variable name of X pointing to that memory, and I'm saying I want to put whatever's over here in there. Okay? Now this 4 is what's called a literal. Now in early programming, we're going to use literals all the time. But when you become a professional programmer, you're almost never going to have literals. You're going to have the value of a field from a database. You're going to have something that the user did, some byte value from some pixel on the screen, the color. You're going to have a lot of different things. You're going to try to avoid literals at all costs. In fact, if you have certain names that you have to load, you're going to load those from a resource file. Because literals in your source code, when you get into professional coding, very, very few. Okay, you don't hard code literals. You load what you need. So, but the bottom line is whatever is on the right-hand side of this assignment operator is going to be evaluated. And if it evaluates to the correct data type, it will store it here. But this better come out to be an integer, or the compiler or the interpreter are going to throw an error. Okay? And this last guy is simply the end of statement indicator in the C-based languages. So what's on the right has to evaluate to a value that can be put in here. So if the right-hand side evaluates to a character, and I'm trying to stick it into a floating point storage, it's not going to work. If this is, and the languages will do things to try to help you. So if this is floating point, and I put it into an int, it's going to lop off everything from the decimal. Well, that could be important, but it's going to lop it off anyway and stick the integer value in there. Okay? If I have a Boolean and I'm trying to stick it into a character, depending on the language, it's going to throw a mistake. If I have a class known as my grade record that I've named, and I'm trying to stick a first name into a class, it's not going to work. The data types of what this evaluates to must be equal to the data type in which it's stored, which if you think about it makes sense. If I have some custom data type trying to stick it into an integer, it's not going to make sense. This is 4 bytes. This is 4 bytes long. If I have some object that's like 37 bytes because it's a class with methods and fields, and I'm trying to shove 37 bytes into 4, it's going to go, what are you trying to do? Okay? So the data type of whatever is evaluated over here has to match. And that is one of the quickest things that compilers can catch, is data type mismatches. And sometimes we need to force the data to be considered the same data type, and that's called casting. Okay, and there's explicit casting and implicit casting, and we'll get into that as we get into the languages. But what I'm doing right now is I'm saying, give me an integer, name it x, and then evaluate what's on this side and store it in this memory location of this size and type pointed to by this token. Okay? That's what's happening with a simple statement. And by breaking it down like this, you can begin to see the abstractions. Okay? Because I have to go to memory and get 4 bytes. I have to create a token, which means somewhere in there, I'm adding this to a table of variables that I'm using within the scope of this block that this statement's in. Okay? Then I have to do some evaluation, which means I could be using the stack to push and pop a bunch of values, because this might be 4 plus a variable value from another memory location. And so it could be doing a lot of work over here and then taking that result and moving it over here. So int x equals 4 sounds really simple, doesn't it? But it's like the duck with his feet moving under the water. There's a lot going on behind the scenes when you really unpack a simple statement. Okay? So that's the power of abstraction, and that is a definition of a variable in the language C. And after this, in the next video, we're going to begin to talk about methods. And they come in 2 flavors, which you will see on the other side.